Okay.
Now I find myself wanting to marry you and take you home. I love.
All right. Welcome aboard, everyone. What are we halfway through week 7? Going by pretty quick here. We are in the midst of probably the hardest, most tedious part of the robotics class, and that's the notes on basic electricity. We've probably got the hardest, most complicated day today. So if you make it through today, it gets a lot easier from here on out. Um, so today we'll be mentioning some of the science aspects of basic electricity, and then we'll get into the little bit more practical aspects of what we're going to be using the electricity for. So there's a lot of different branches of electricity. There's completely hands-on people that work just hands-on building with electrical components, fixing them, maintaining them, diagnosing problems, that kind of stuff. That would be more of your electrician or electronics technician. Sorry, I had somebody jump in. Okay, so that's going to be that side where you're doing a more physical approach like that. Rody, that's tripping me out. Looks like you're floating through space. He's got that movable background and he looks like he's driving around and it's hilarious. Uh, anyways, so there's that hands-on side of the electrical world. And then on the opposite extreme are the people that are really theoretical on the science side of it that look at it. And in those cases, you're going to see things like chemists, physicists, sorry, and then also like electrical engineers and computer engineers and electronics engineers and that side. So, and then there's everything in between too. So there's lots and lots of different jobs in the electrical field. If you like the science side of it, there's lots of jobs on that side. If you like the hands-on practical side of it, there's many, many jobs in those fields as well. All of those jobs are in really high demand. All of those jobs push us into the future, whether it's coming up with new creations with electricity or new software developments or new applications for electricity, or on the other side, just building and maintaining our electrical like infrastructure, a grid. So tons and tons and tons of jobs in these fields. They're also some of the highest paying jobs out there. So that's always a big plus too. It's nice when the thing that you like is actually paid really well. So any of these kind of things are very high end. And then on top of that too, there's the electronics field. We're not talking about that just yet, but there's also, that opens up a whole new field as well and many, many other careers. So let me pull up the notes. And if you guys could pull up your notes that you started as well too. And again, I'll try to keep your notes as simple as possible and make you write the least amount that you need to. But there is some stuff that you need to do. Okay, Williams is here. Okay, so remember, if you had not started it yet, you need to start a new Google Docs called Basic Electrical Theory or Basic Electricity, something like that would be fine. Share screen. I put the specific directions in your slides, so if you want the exact name, you can look it up in the slides. Okay, so here is our basic lesson so far. So we'd already talked about electron theory versus conventional. Just to recap, remember electron theory is what physics found to be the truth, and that is that electricity moves from negative to positive. Okay, so now that you know that's the reality, you're going to kind of throw that theory away for this class. Okay, so that's the reality, that's the truth of the world, how the world works. But when you deal with electricity, everyone that deals with it's going to use conventional theory, and that's that electricity flows plus to minus. Okay, so when we read wiring diagrams, we need our electricity to flow from the positive side to the negative side. That'll be very important when we start doing wiring diagrams. Those are awesome. It's kind of like learning a foreign language, but it's the language of electricity. And it's something that all of us electricians can communicate with, and most other people look at it and they couldn't tell what the heck's going on. So cool stuff. We'll get into that a little bit later though. Okay, hold on. I just saw there was a comment. Let me see if that's something I need to. What exactly are you looking for the link for, Michael? Which link? there's no link for the notes yet. So you are making a new Google Docs and you're going to title it Basic Electricity. Okay. If you want the directions on how to do it, it's in my slide directions, the one for the process journal and Otis and the library. So you could look at those two. That's the directions for it. Once we're done taking notes, I will actually post my notes there as well, but I haven't made that link live yet, and I won't until we're finished with our notes. Because what I don't want you guys to do is just copy and paste, okay?
I could copy and paste if you'd like.
Sounded like somebody was saying something, but I could barely hear you, so speak up if you were.
It's like us. We go from the negative to the plus.
We do?
Yeah. The negative is the babies.
The negative is the what?
Is the baby.
Oh, you're thinking like negative is smaller, right?
Yeah.
Okay. That's funny. I was thinking of negative as the opposite. Like there's a substance and then negative is the opposite of substance. I was trying to follow you. Okay, that makes sense. So that's the way we look at it in electricity, from plus to minus, okay? That'll be important when we look at things like diodes and light emitting diodes, because sometimes the flow of electricity is important to us, okay? That's also how we're going to change alternating current to direct. So I know that doesn't make sense, but all we need to remember is plus to minus is how we're going to be doing it in this class. Okay. Then we also said that matter is the basic building block. Oh, I'm sorry about that. So matter is the substance. It could be a solid, a liquid, a gas, but it's anything you see, like the desk, the stool, the chair you're sitting on. Any of those things are matter, okay? And then matter could be broken down into molecules. So this is a very basic chart here. Matter could be broken down into molecules, which can then be broken down into atoms, okay? And we do have elements in there too, like the periodic table of elements that you learn about in chemistry. I'm just gonna flat out tell you, I don't know anything about chemistry. I thought it was the hardest science class I've ever taken in my life. I barely understood it, and I wish I did more, because chemistry is like magic. The things you can do with it, you can make explosions, you could make smoke, you can make things melt, you could make two different things form into a third one, you can make two liquids form into a solid. It literally is like magic personified. And my worst friend in the world is a chemical engineer, and we always talk about this stuff, but he can go off on crazy directions I can't even understand. So yeah, it is. Chemistry is the modern alchemy. And it's funny because alchemy was the theory of you could do magic with liquids and stuff, but chemistry, actually you can do magic with it using science. So it's kind of a cool evolution. Like I said, I love chemistry. It's very interesting, but I cannot understand it for the life of me. For whatever reason, it just doesn't sit well in my brain. And I will point out, chemical engineering is the second highest paid engineering field right out of college, okay? So the highest paid is petrol engineering, which is oil. And then the second highest paid major out of college is chemical engineering. So it's very, very well paid, okay? Yeah, they're always looking for gold, exactly. That's what alchemists were supposed to do, turn lead into gold. Very good, I like that. We got some Harry Potter references too. I gotta say, I was so glad. I love fantasy writing. I was really glad when Harry Potter came out, because introduced a whole new generation of fantasy stuff. Okay, where the heck did my notes go? Let's see here. Is it that one? No, this one? Okay. All right. So anyways, long story short, every piece of matter that you see could be broken down into smaller and smaller pieces, okay? Now, I am not up to date on this, but the science, it's one of the most cool parts of science is they're coming up with smaller and smaller breakdowns of what matter actually is. So the last one I can remember, which was new technology when I was going through college, was quarks. Quarks were the smallest piece of, like you could keep breaking stuff down, smaller and smaller and smaller, and quarks were the biggest. Well, since then, I think they found two more things that you could break quarks down into. And so they're getting smaller and smaller. And it's really kind of complex to even understand some of these, because they're so like theoretical on the physics level, and they're doing a lot of experiments to solve these things. And it's important because it's how everything is made up, are these smallest bits of particles. But they keep finding more and more stuff. So as you go through college and you study some of the newest scientific findings, you'll find they're just smaller and smaller and smaller. And it's one of the things that helps us with all this nanotechnology as well. So it's cool stuff. You'll get a little more of it in college. I'm not qualified to talk about all those tiny little bits, but we don't need to get that small. We're going to stay at the atomic level, okay? Quartz, no, it's not quartz like a crystal, and it's not quarks. It's, how do you spell it? Q-U-A-R-K or something like that.
Quark.
Yeah, I can't. If you look up small particles quarks, it'll pop up. Yeah, and like I said, I think there's 2 levels smaller than that now too. Yeah, Q-U-A-R-K, I think is pretty sure.
That's how you spell it.
Okay.
The teachers that we had were liars. They said atoms were the smallest.
So when your teacher went through school, atom was the smallest.
They
Okay.
lied to us.
Yeah. So, well, I shouldn't say that, because atoms are protons, neutrons, and electrons. And we knew that when we went through college. But all of this stuff I'm telling you about, it's new. It's all new. It's within like the last 30 years, 20 to 30 years. So the quarks were like 30 years ago, I think we found, maybe 25, something like that. But these newest ones, they're literally within the last decade. Physicists keep like trying to prove some of their theories. So it's really cool stuff, but you have to be really smart at science and you have to be on the cutting edge. Probably most of your teachers aren't going to know that stuff. You know, maybe your science teachers will, maybe if they stay up on all the journals, but they might not too. It just depends. Cool thing with science is we're always finding out more and more information, even with histories that way too. Anthropology, archaeology, they're finding more and more stuff all the time as they unearth more and more sites. So we're getting more information. That's the cool thing with science. It's like a giant detective. You're like a detective in a giant world of mysteries. So really good stuff. That's why I love science. If you guys like science, follow it, because there's tons of cool jobs in that. And truthfully, just like we in the trades build the infrastructure for America, scientists build the infrastructure for our like capacity to grow as human beings. So both integral to our advancement as humans. Okay, sorry, I've been yakking too much. You can see I like this stuff a lot. I think it's really cool. And I love seeing you guys getting exposed to it and interested in it. It's really neat. Okay, so let's talk about the atom, okay? The atom is very, very small. Remember, we're starting at matter, like your desk. It's gonna go down to molecules. We got elements, and then we got atoms, okay? And so the atom is, let's just call it the basic unit of matter, okay? Again, for the longest time, atoms were thought of to be the smallest things. Then we found out that protons, neutrons, and electrons, and then for the longest time, those were thought to be the smallest. And then, like I said, they keep finding smaller and smaller. But we're going to stay at this level because that's all we need for electricity. So I want you to put into your notes atom, and I want you just to put it's a basic unit of matter, okay? So atom, basic unit of matter. Look at you guys already getting into the valence rings and stuff. We'll be getting there. Okay, so the atom is a basic unit of matter. And I'm just going to read a little bit to you. It's got a central nucleus, which probably most of you guys know, surrounded by a cloud of negatively charged electrons. Okay, the atomic nucleus, this part in the center, contains a mix of protons and neutrons. So that's positive and neutrally charged bits. And then the outside rings are the electrons. Okay, and that's what we're focused on in the electrical classes. We actually care about the electrons. So if you look at that picture on your left there, you're going to see that there's a center to it. That's the red part, and that's going to be the nucleus. So let's go ahead and put nucleus in our notes. So far, all you're writing on this, and like I said, this is the densest part we're gonna do. So if you make this, you're okay. So the first thing I want you to write is the atom is the basic unit of matter, okay? Atom, basic unit of matter. And then I want you to write nucleus, okay? And then put like a hyphen or a colon, and then next to nucleus put, that's the center of the atom, and it houses protons and neutrons, okay? So like I said, I know this is dense, I apologize. So far, atom is the basic unit of matter, and it has a nucleus, which is the center of it, which has protons and neutrons, and that's gonna be the positives and the negative, or sorry, the positives and the neutral charges.
Are we in docs or slides?
Could you speak up? I didn't quite catch that.
Are we going to do this in docs or slides?
This is in your Google Docs.
Okay.
Okay, your whole Google Docs will be linked to a slide later, but for now you're just taking notes. Okay, so hopefully everyone's got that. Atom, basic unit of matter. It has a nucleus, which is the center of it. It has protons and neutrons in there, okay? Positive and neutral charged bits, okay? That's the center of it. And then on the outside ring, you're gonna write electrons. So outside of that nucleus, on the outside rings, it's gonna have electrons floating around, and electrons are the negatively charged. Fantastic. I'm just going to read this because it'll be posted on the video. But Samar put, why did the atom not laugh at his friend's joke? It was no laughing matter. I love the nerd jokes. Okay, let's see. So just to remind everyone, we have the atom, the whole atom. Inside the center of it is the nucleus. We've got positive and neutral in the center. And then on the outside in these rings, we have the negative electrons, okay? And those are what we're going to be talking about. That's electricity. Those electrons moving around are going to become electricity. So when electrons jump from this atom to another atom, we have electricity, okay? So that's what we're going to be talking about. Now, I'm going to go over this part here, but do not write this down, okay? This is way beyond what we need for this class. And this is getting into the edge of my knowledge. I don't understand valence rings and positive ions and all that. It quickly went out of my grasp with chemistry, okay? So there's an outer ring, and that's where the electrons flow. In fact, there's many rings usually. There's multiple layers of rings, and they move in different directions. And usually the outermost ring is the one that we're worried about with electricity. And in that outermost ring, we can have electrons that will jump out of one of these atoms and move to another atom, okay? And that's electricity. And the way that works is the outer ring is called the valence ring, okay? The valence ring. Again, don't write this down, just kind of listen to it, okay? The valence ring is the most outer ring, and it's the number of electrons in that orbit that determines whether that atom is a good conductor or insulator of electricity, okay? And what determines that is the number of electrons in that outermost ring. So it might have many rings filled with electrons, but the outermost ring is the only one we're worried about. And if it has if there are less than 4 electrons in that valence ring, then it's considered a conductor, okay? Conductor will conduct electricity, it'll pass electricity. And if there's more, 5 or more, then it's considered a insulator, okay? It does not pass electricity well. So again, what we mostly care about is that outer ring of the atom, because that's where the electrons are. And then of those outer rings, we really only care about the outermost one. And then we only care if it has, then we only care about the amount of electrons, because we want to figure out, is this going to protect us from electricity, or is it going to help us pass electricity? Both are important, both are critical. And then you'll see there's these things called semiconductors that developed into the computers that we know today. And those are the ones that are right in between and can go either way. So we'll find out about that a little bit later, okay? So that's the valence ring. That's how you got to understand electricity. We don't need to understand that to actually use electricity, but that's how it works, okay? I don't want to go over this one with you guys. Again, this is from my college class, so some of this stuff I'm not having you guys learn. Okay, let's skip that. Okay, very nice. This will probably be the last thing for today. Again, that was the hardest part of the whole lecture. Everything else will make a lot more sense after that. Somebody's asking about silicone already, the magical semiconductors. So those are the ones that are right in between. We'll spend more time on those in a little bit. Let's see. Okay, so let's start with conductors. You definitely have to put conductors into your notes. This is actually what we do in electricity class. We use conductors, okay? So here's what a conductor is. It supports the flow of electricity. So you guys need to understand that. We'll be talking about conductors all the time for the rest of the year. You must understand that. So put this in your notes. Conductor supports the flow of electricity. Okay, and then you need to know what are some good ones. In general, metal is a very good conductor, so anything with metal in it is going to pass electricity back and forth. However, some metals are better than others, and typically the more expensive and rare the metal is, the better it is with conducting electricity. All right, I'm killing chat for a second here because I want you guys paying attention to this. Okay, so again, get this into your notes. Conductor supports the flow of electricity, and metal are examples of good conductors. So put a couple of examples of what a conductor is: copper, gold, aluminum, steel. In general, the more expensive a metal is, the better of a conductor it's going to be. So copper is a good compromise. It's a good conductor, and it's relatively cheap, although it's still pretty expensive, especially nowadays. But as you go up, like silver's a little better, gold's even better, platinum's even better. So the more rare it is, usually the better it is at conducting electricity.
Isn't silver the best conductor?
No, I do not believe so.
Yeah, I think it has the highest conductivity. I just know that because it tarnishes.
I don't know. Let's look it up real quick. Let's see. Pure silver looks like the best. They say aluminum here, though, has high conductivity, and aluminum's not as good. Copper is used as like the best compromise from cost to levels. I wonder why they're not gold. All the computer chips use gold, not pure silver. So that's surprising to me because they need the best.
Silver
They need the
tarnishes
best conductance.
the best conductor. The gold doesn't tarnish. It's almost as good.
You're real quiet if you're trying to come through.
It also, when silver isn't tarnished, it's actually best at reflecting light.
Here, I'm gonna turn chat on real quick. Okay, so that's let's see. Okay, so I'm turning chat back on. Anyways, guys, that's all I'm gonna do for the lecture today. So there's only a couple minutes left. I'll just give you a few minutes to finish up your notes, or if you need me to grade anything or something, we can do that. But anyways, if you're good to go, you're free to leave, and I will see you guys back tomorrow. If you have any questions, feel free to stick around.